Okay, you guys, we're taking a look at 4.3 today. It's applications of systems of linear equations, which basically means word problems. Word problems that have systems of linear equations, which means word problems that have 2 or 3 variables. Okay, we're going to approach these with the very same 4-step strategy that we approached our 1 variable equations with. We're going to take step 1 and label, identify all of our knowns. Every number that they name in their problem, you're going to want to write down, and you're going to want to label it. And the unknowns, you want to label them. In your unknowns, you're going to have variables. And part of what they do with a 2 variable equation is for every unknown, we give it a different variable. Every unknown, they give it a different variable. So just keep that in mind, that we'll have some x's and some y's. We'll have 2 different, and then when we set the equation, keep this in mind also. We already know that we're going to pay attention to the relationships and phrases to set up our equations. When we have 2 variables, we're going to have 2 equations. If we have 3 variables, we have to have 3 equations. So when you're solving a system of equations, you have to have an equation for every single variable in order to do an elimination procedure and solve for each variable. So after we've set up the equations, 1, 2, or 3 equations based on how many variables we're working with, then we're going to solve for all of our variables. We have the techniques that we've learned. We're solving using substitution, we're solving using elimination, and we have our 3 variable step process that we did in 4.2 that we can use. And those are all of our techniques for solving for variables. And then when we're through solving for our variable, we're going to make sure we're answering the question and labeling the answer. Okay, so before we jump into this lesson, I do want to give a little bit of a disclaimer and to say that I'm a fan of doing it the way that is easiest for you. And so if it already works for you to set up things as a 1 variable equation, and you see a way to solve an equation using only 1 variable, I'm okay with you using a 1 variable setup in a problem in this section. So this section will have, for example, they'll have some mixture problems. And we talked about how to do the mixture problems in the last chapter. And if you master that method and you want to keep doing that as a 1 variable equation where you have this is x, and this is 0.1, and this is 10, and this is 0.2, and this is x plus 10, and this is 0.15. And if you're content with that method, then there is no reason for you to change methods. So we'll work some together and get a chance to try it out. I am going to switch to a different screen because these screens with all these notes kind of crowd out all of my workroom. So I'm going just to a really stripped down version of 1, 2, 3, 4, so it'll have a little bit more screen room. All right, we are on page 234, exercise example 1. Okay, we're going to read the problem and we're going to start labeling our unknowns. Okay, we have a rectangular soccer field. Let me just draw my soccer field. We have a rectangular soccer field. It may have a width between 50 yards and 100 yards. So width is going to be between 50 and 100 yards. And the length is going to be between 100 and 130. Oops, let me draw my sign. Okay. One particular soccer field has a perimeter of 320. Its length, okay, we know we're going to have a length and a width. its length measures 40 more yards than its width. Okay, if we were assigning variables, everything in that case is based on width. So that's W, and the length is 40 more, that's plus 40. 40 more than what? Than the width. And so as you can see, when I'm setting this up, my brain just naturally moves to doing it with one variable. The beauty of me doing it with one variable is now I only need one equation to solve my problem. So let's solve it right quick using one variable. Then I'll come back and show you how to do the same problem using two variables. And you can say, you can look at both, understand both, and then have the ability to choose the one that works best for you. How's that? Yikes. I messed up my slide. Okay, so as a one variable equation, I've got some information that they've not really shown me how to use. They've given me this, but they've not shown me how to use it. I know how to work my way around a perimeter formula. What they've not told me is that the perimeter formula is 2 length plus 2 width. And I can now sub in 320 for perimeter, 2 times the length, and my length is W plus 40, plus 2 times width, and width is W. So then that turns into 320. Distributive property would be a 2W plus an 80 plus a 2W. So I get 320 is 4W plus 80. We're going to subtract 80 from both sides. 80s cancel. 4W equals, that would be a 4, 240, and W equals 60. Okay, now W is 60 what? 60, my unit is yards, so width is 60 yards. And I'm just going to make it easy and label it right here. $60 yards is my width. Okay, if that's my width, then length would be 60 plus 40, so 100 yards is my length. Now, let's see about this information that we were given up here, because it looks to me like now we need to do a reasonability check and see if these measures fit within the allowed measures for dimensions of a soccer field. So here we go. The width is 60. That's in between 50 and 100, so that is an acceptable width. The length is 100, and that looks like we're barely making it on the width. We could be equal to 100. We can't be any smaller. So our measurements for this soccer field make it meet regulation lengths and widths for a soccer field. Okay, now let's go back. Hang on. Okay, let's go back and let me show you how to do that. Here's my rectangle. And if I started off, I wouldn't have be labeling them both. I wouldn't label them both in terms of W. I would call L as length and W is width. And I would immediately put my perimeter formula, 2 length plus 2 width. And then from there, I would put in the values that I've been given. Let's see. So we have perimeter is 320. And they said that the length measures 40 yards more than the width. So the length is 40 more than the width. Okay, so if I wanted to balance those out, the length is already 40 more. So I would have to add 40 to the width to make them equal, because right now the length is already 40 more than the width. So to make them equal, I would have to add 40 more to the width. Okay, and then I've got this equation where 320 is going to be 2 times my length plus 2 times my width. So these are going to be my two equations. This is the information I've been given, equation 1 and equation 2, for my problem. And I'm ready to use substitution. I've got, when I'm solving, I can use substitution, elimination, or with the two variable equation. So I'm going to put in a W plus a 40 in for my L. So we'll sub it in. So 320 is going to equal 2 times L, and L is W plus 40 plus 2W, and then there we go, 320. And you're going to get, I want you to see that we end up in the very same place as we did with the one variable equation. In this problem, you can see that eventually all roads lead to Rome. Eventually we get there to the same equation, to the same solution set, whether we had it there with one variable or two variables. Okay, example 1. Let's take a look at example 2. Now, example 2 is the mixture problem. And let me just tell you, I'm not in favor of taking something that's working and adding confusion to it. I think you guys have a really good grasp of how to solve a mixture problem with one variable. I don't know that there's a need to do it as two variables. If you're having problems with the one variable method, talk to me and I will work with you to find out if we need to clarify the one variable method, or if you would prefer the two variable method. I'll help you in either way. So let's look at example number, whoops, I just skipped an example. Never mind. Example 2 is not mixture. Example 2 is about tickets. It's at the bottom of page 235. For the 2008-2009 National Hockey League and the National Basketball Association seasons, 2 hockey tickets and 1 basketball ticket. What are we tracking? We are tracking hockey tickets and we are tracking basketball tickets. I'm having fits with my pad. It's not printing at all. I'm having to really bear down. And then it'll suddenly start happening where it's working. Okay. So B is for basketball tickets and H is for hockey tickets. Let's go find out what they're going to tell us about it. We're looking to set up 2 equations. Okay. So 2 hockey tickets and 1 basketball ticket purchased at their average prices would have cost $148.79. So let's put that into a sentence. 2 hockey tickets. Well, we take 2 times H, whatever the cost of hockey tickets are, plus 1 basketball ticket. That's 1B, and it's going to equal $148.79. Okay, next, 1 hockey ticket and 2 basketball tickets. Let's write that down. 1 hockey plus 2 basketball, and that's going to equal $148.60. Those are relatively close in cost. Okay, that's our 2 problems. Let's see if there's any more information. What are the average ticket prices for the 2 sports? Okay, you guys, what do you want to do? We are at the point, we have 2 variables. we have to solve it. We can do substitution. We can do elimination. I'm just in favor of doing elimination. I don't know why I typically go there, but I would want to multiply this whole row by a -2. And if I multiply that by -2, -2 times 1 is a -2. -2 times +2 would be a -4. And let me use a calculator. We have a 148.6 times a -2 turns into a -297.20. All right, let's go. I don't like my 4. Pardon me. I'm really not a perfectionist. I just don't want my work to be so confusing you can't read it. All right, our h's cancel. -3b equals 297. It's -148.79 is positive. Gives me a -148.41. Divide by -3, divide by -3. And I get a positive $49.47. $49.47, and that's B. So that's my cost of my basketball ticket. All right. To solve for H, I go into an original equation. 2H plus 49.47, that would be 1B, equals 148.79. Will be 2H, subtract 49.47 from both sides. So 148.47 minus 49.47, and I get $99. And so H is going to be $49.50. And I knew they were going to be really close. Let me put is this hockey? And we're going to read the question. Let's go back and read the question. The question says, what were the average ticket prices for the two sports? So we've got our answer right here. We've got the ticket prices for both of our sports. I knew at the beginning in this equation here, when both of the original amounts were really close, one was 148.79 and the other one was 148.60, I said, yeah, we're selling 3 tickets all together and they're about the same cost, so the tickets themselves will be about the same cost. And the reason I brought that up is if you'll pay attention to your information, it'll give you a really good sense of what's a reasonable answer, and you can catch yourself or catch the mistake early on. Okay, here we go. We're on example 3 now. Example 3 is a mixture problem. I'm just going to remind us about our mixture problems, and we'll solve it as a one variable equation. In a mixture problem, what goes above the line is our volume. They're going to give us some volume information. And on the bottom is going to go our purity. And it's going to be written as a decimal. They give it to us as a percent, but we're going to write it as a decimal. And we have solution 1. Sometimes we'll have 3 solutions, but most of the time we have 2 solutions. And then we have the solution that is the mixture. Okay? Now, what we'll always know is that volume 1 plus volume 2 is always going to equal volume 3. So if they don't give us one of these, we'll subtract back or add, whichever one we need. We would add these two to get the third, but we would subtract this value to get one of these two. So we always have this relationship as a part of our strategy base, that our volumes of our two solutions equal the volume of the, and I have a 3 here, but really that would be an M. The volume of solution 1, the volume of solution 2 equals the volume of the mixture. Okay, the next thing we know in terms of what kind of equations, equalities, always exist in this type of a dynamic is that this is our volume 1, this is our purity 1, this is our volume 2, this is the percent purity of 2, this would be the volume of the mixture, this would be the percent purity of the mixture, and we have a multiplication relationship there, that volume 1 times purity 1 as a decimal multiplied together, and you add that to the volume 2 times purity 2, and that equals the volume of the mixture times the purity of the mixture, keeping in mind that all of our purities are in decimal form. So I just want to remind you, we know those equations, we know those equivalents going into this situation. So let's listen to our problem and start organizing our information so that we can create equations and solutions with one variable so that we can do a one equation hit. All right, how many ounces, that would be an X for my volume, how many ounces, X, of a 5%, 5% would be a 0.05. 5% of a hydrochloric acid and a 20% hydrochloric acid, that would be a 0.2, must be combined to get 10 ounces of a solution that's 12.5%. So that would be a 0.125. All right, I have a missing volume. And so I know my total volume is 10. So if I take my total volume and I subtract X out, that's what my volume 2 is. So 10 minus X is my volume 2. So there you have it. Okay, what relationships do we know? If I multiply volume times percent purity of each one, I'll get an equation. So 0.05 times X plus 0.2 times 10 minus X equals 0.125 times 10. Okay, when we multiply that out, we're going to get a 0.05x plus the 2 times, that's going to be the whole number. 10 times 0.2 is going to be the whole number. 2, move that decimal one place. 2 times 10, and then we do a 0.2. So that's a minus a 0.2x. And that's going to equal, move that decimal one place, and I get a 1.25. Okay, let's combine like terms. We have two x terms. The 2 is negative, a negative 2 plus a 0.05 turns into a negative 1. Oh, wait a minute, wait. I had the wrong number. I had the whole number 2. 0.2, and it's negative, plus a 0.05 is a negative 0.15. You know, that messes with my brain. That's correct. That's correct. Negative 0.15 plus 2 equals a 1.25. We're going to subtract 2 from both sides. And I get a negative 0.15x equals a negative 0.75. Let's divide both sides by 15.75 divided by 0.15, and I get x. Negative and negative will be positive, is a positive 5. X is a positive 5. Okay, so what is the question? Let's go back to the question. How many ounces of each? How many ounces of each? So I need, that would be a positive 5. I need 5 ounces of 5% hydrochloric acid, and I need, and it's going to be 5 ounces, 10 minus 5 ounces of a 20% HCl. And there you have it. Box my answer. That's example 3. Okay, example 4. Example 4 is a motion problem. So let's get our box in place. And we have a car and a truck. In a motion problem, we have rate times time equals distance. All right, let's find out what we've got going. The car travels 250 kilometers. So our distance is already known, is traveling 250 kilometers in the same time. So what does that mean? Car time. In the same time, a truck travels 225 miles. So car time equals truck time. How do I know that? I saw the word same. And I'm going to mark that down because I don't want to forget that. Car time is the same as the truck time. That's going to help me when it comes to equation time. If the rate of the car is 8 kilometers faster than the rate of the truck, what's it all based on? It's all based on the truck. So the rate of the car is 8 kilometers faster. It's going to be driving faster. Find both rates. Okay, so what they've not given us this time is the time. We don't know the time, but we also have a formula. We have a formula that says distance equals rate times the time, so we can just solve for time. We'll divide both sides by rate. That cancels right here. And time is distance divided by rate. So my distance is 250. My rate is x plus 8. My distance is 225. My rate is x. Okay. All right, that's good to know because now my car time is going to equal my truck time. So my car time is 250 over x plus 8. And my truck time is 225 over x. You guys, everything we've been doing in every chapter up to this point makes this an easy problem. The fraction doesn't look nice, but it's cross products and distributive property and solving for one variable. So we've got all of that. 250 times x is 250x. And that's going to equal 225 times x plus 8. So let's solve that. 250x is going to be 225x plus, let me pull out my 8 times 225, and that becomes 1,800. Okay? Minus 225 5x minus 2 to 5x. Cancel, cancel. And I've got 1800.
Hear me?
I've got 1800 is 25x. Divide by 25. And x is 72. Let me see. Sorry, it's my son. I'm at nighttime doing this, and he doesn't know I can't talk right now. Okay. What's our question? Let's go back and find out. Our question is, find both rates. So X up here was our truck. So the truck is going to be traveling at 72, and it's a rate, so it's miles per hour. And the car is going to be 80, and it's going to be miles per hour. All right, there we go. Now, if you wanted to solve that with a two-variable approach, what you would have done here, let me show you the distinctive. Same information, same relationships. Let's talk about how we would have managed it. We would have had a scenario where the rate for car is unknown, the rate for truck is unknown. They're wanting to know the rates, so we assign them two different variables. So I might assign car a C and truck a T, because I tend to correspond my variables to my actual item. So in a scenario like this, I would have said, this was a C and this was a T. And our time, remember we solved time was distance over rate. So that would be a 250 over a C. This would be a 225 over a T. We still have that car time equals truck time. So one of our equations would be that 250 over C equals 225 over T. And we would use cross products, and we would get 250 T equals 225 C. All right, that would be one of our equations. We have two variables. We have to have two equations. So what would we have for the second equation? Well, they gave us a little bit of information about the rate. They said the rate of the car is 8 kilometers faster than the truck. So the car is already 8 kilometers faster. If I want to make the two rates equal, I'm going to have to take the truck's rate and add 8 to it. The car is already 8 faster, so I need to add 8 to the truck to even that out. So I would have car equals truck plus 8. Now, in this dynamic, I have two equations. Let me erase what I don't need so that you guys can focus on the problem. I can do a substitution right here for C, right there, and get 250 T equals 225 C, and C equals T plus 8. And from there, it just becomes a solution step process. Distributive property in combining like terms, solving for your variable, all of those steps, and it'll bring you back over here to where car and truck will be those values. Okay, so if you want to set it up as a one variable equation, you can. If you want to set it up as a two variable problem, just remember that you need to set up two equations. Okay, let's take a look at example 5. Example 5 and example 6 are 3 variable problems. So yay, yippee, yippee, yay. We will have to do all 3 variables, and we'll have to use the solution step, the 3 variable solution step that we learned in 4.2. So in example 5, we're at Panera Bread. We're buying a loaf of honey wheat bread. We'll call that X. Is honey, I'll just do honey wheat bread. We'll choose Y, and Y is sunflower bread. And we have Z, we have French bread. 3 types of bread. Okay, now they've told us the cost of the bread. So I'm going to go ahead and assign that cost. The honey wheat bread is $2.95. So I'm going to have an equation that says 2.95 times my honey wheat bread, which is X. And my sunflower bread is $2.99. And my sunflower bread is a Y. And my French bread is $5.79. And my variable for that is Z. And they're giving me, let's read the whole problem. On a recent day, 3 times as many loaves of honey wheat bread were sold. We'll come back to that. The number of loaves, I'm listing for a total. The number of loaves of French bread were 5 less. We'll come back to that. The total receipts were $87.89. $87.89. So every time I sold a loaf of one was $2.95 a loaf, another was $2.99 a loaf, and the other was, and that ended up being $87.99. Okay, so that's one of my equations. I've got 3 variables. I'm going to need 3 equations. So let's go listen to the information and see what we can come up. On a recent day, 3 times, I'm going to write it down here, 3 times as many loaves of honey wheat were sold as sunflower. All right, so the honey wheat was 3 times the sunflower. If I want them to be equal, I'm going to have to take the number of sunflower and multiply it by 3. Okay, honey wheat has the variable X. So, and sunflower has the variable Y. All right. So we have equation number 2 in the works. Let's go for equation number 3, and let's take the last relationship they give us and put those words into an equation. The number of loaves of French bread sold was 5 less than the number of honey wheat. So French bread was 5 less than honey wheat. I would have to have French bread. Oops, that's not an F. French bread was 5 less, so I'm going to have to add 5 to my French bread to make it equal to my honey wheat. French bread is a Z, so Z plus 5 equals honey wheat, which is X. Okay, let's take that and write it up here. And I'll erase this. Now, if you can see, if we've got the 3 variable system of equations, we're going to need to put them all in standard order. So I'm going to need to put the X term first, the Y term second, and my constants go to the far right. So in my first equation, I'm going to have to adjust that by subtracting 3y from both sides and get an X minus a 3y equals a 0. Here I'm going to need to move, probably the easiest thing is to move z over. And that would be an x minus a z equals a 5. An x minus a z, that cancels, equals a 5. Okay, so now we've got our equations written in standard order. We're going to need to study them and say which variables do we want to eliminate. And which one do we want to be our working equation. All right. Well, let's make this equation 1. This can be equation 2. And we'll let this little beast be equation 3. All right. We're going to first take a look at equation 1 and 2. And what I would need to do is probably multiply equation 2 by a -1 so that these x terms would cancel. I'm going to let x be my focus variable. And we'll cancel x's. Okay, let's do that. So I get an x minus a 3y, this is equation 1 and 2, equals 0. Multiplying a -1, I get a negative x. And I'm going to have to move this little jewel over because I've got to make room for a z. I've got to line up my like terms. -1 times the negative z gives me a positive z, and that equals a -5. Okay. Cancel, cancel, and I get a -3y plus a z, and that equals a -5. That is my equation 4. Okay, let's go to equation 5. We're going to take our E1 and pair it with our E3. And to cancel my x's, I'm going to need to take E1 and I'm going to need to multiply it by a $2.95. Multiplying it by a $2.95. Okay? Unfortunately, I worked this differently when I worked it by myself. Now I have to do all my numbers again. Okay. So we have a 295 x plus a 299 y plus a 5.79 z, and that equals an 87.89. Okay, a negative 295, $2.95 times x would give me a negative 2.95x. Okay, a negative 295 2.95 times 3 is a negative 8.85. And a negative 295, oh, that's a y. And a negative 2.95 times a 0 is a 0. These two cancel, and 2.99, 5.86y, it's negative, equals 87.89. We'll take an 87.89 and divide it by 5.86, and we get ooh, I'm not happy. Let me see if I'm doing the math wrong. I clearly have made a mistake. Wish you could tell me where it is, because you guys are watching this. 295. Okay, I think I found it. 2.95 times 3. Nope, it's 885 minus 2.99. 586. 8789. Oh, I see my problem. I'm solving and I'm not supposed to be. I don't have a z term here. I have a 0z. So this I'm working on equation 5. And that equals an 8789. And that's E5. And on E5, I have a y term and a z term, a y term and a z term. Okay, so let's take our E5 and our E4. We'll run them together. Okay, so E4 is a 3y, and it's negative, plus a z, and that equals a negative 5. And E5 is going to be a negative 5.86y plus 5.79z, and it equals an 87.89. All right, let's make these two equations cancel. The easiest way to do that is with z's. We'll take this z equation and we will multiply it by what we need to multiply it to cancel our z's, which will be, I'm making room, which will be a negative 5.79. Okay, negative 5.79 times 3 is a negative times negative is going to be a positive 17.37y minus 5.79z, and the 5.79 times a 5. Those are both negative. It's going to give me a positive 28.95. Okay. That will cancel. Let's line them up. The negative, negative, the negative 5.86y plus 5.79z equals 87.89. Our z's cancel. Let's 17.37, 17.37 plus a negative 5.86 gives us a positive 11.51, and that equals 28.95 plus 87.89. 116.84 divided by 11.51. Do that again, 116.84 divided by 11.51. Ooh. So you guys, I worked this totally different and started off on the wrong foot. When I made the E1 different than when I did it on myself. I wasn't paying attention. So I'm going to go back to the math. 5.79 times 3 is 1737. And 5.79 times 5, 28.95. Wowzer, wowzer, wowzer. 28.95 is a negative. So that's a positive. Okay. Okay, at this point, it is really late at night, and I am extremely sleep deprived. And the biggest and most unfortunate part is not the sleep issue, it's that my actual work had to be erased. So I can't actually find the error of what I did wrong. So let me assure you, our steps are right. Our math is wrong. But when we divide and solve for y, had my numbers been right, y would be 4. So we're going to have to go back to y is 4. Then we go into this one of these original equations and solve for. Let's do this one. A negative 3y plus z equals a negative 5. So let's put in a negative 3 times 4 plus z equals a negative 5. Negative 12 plus z equals negative 5. We'll add 12 to both sides. And that cancels, and z equals 7. Okay, these two answers are correct so far. And what we did was had we done our computations right in one of the steps that preceded this, y would have been 4. That we are then going back into one of our original E4 or E5 two variable equations, subbing in, and we could put in the value of y into this one or the value of y into that one and solve for the value of z. Z was 7. We've got a y is a 4 and a z is a 7. Let's go back into one of our original equations. We're going to need to solve for x, where the equation x, or E1, was x minus 3y equals 0. So x minus 3y is 4 equals 0. X minus 12 equals 0. X equals 12. All right. Those are our values. If we go back now and check them into each of our E1, E2, and E3 equations that we began with, these values would check out. In our final answer, they're asking us to answer the question, how many loaves of each type were sold? So X corresponds to honey wheat. So we had 12 loaves of honey wheat. And we had Y corresponds to sunflower. So we had 4 loaves of sunflower. And Z corresponds to French bread. And we had 7 loaves of French bread. And that becomes our answer. Okay. One last problem we're going to take a look at. It's one more of the three variable equations. This is a pretty big problem. I'm going to need to lower that down just a little bit. So they're going to give us a lot of information and we're going to want to track it. I'm going to actually track it over here. Let's do that. We've got model X, we've got model Y, and we've got model Z. And for these models, we're tracking 3 bits of, so we have a company that's producing flat screen televisions, Model X, Model Y, and Model Z. And each Model X, to make it, requires, we're going to break it into categories. We have electronics work, we have assembly line time, and we have finishing time. So we have, where's my, okay, electronics. We have assembly. And we have finishing time. For each of these models, we have to, we're building these flat screen TVs, and so each of these models have a certain number of required times in each category. So let's track it. Each Model X requires 2 hours of electronics work and 2 hours of assembly line work and 1 hour of finishing time. And each Model Y requires 1 hour of electronics work and 3 hours of assembly time and 1 hour of finishing time. And each Model Z requires 3 hours of electronic work and 2 hours of assembly time and 2 hours of finishing time. Now, in addition, they're telling us there are 100 available hours for electronics. So let's come over here and give ourselves one more column. These are the hours that are available. We have a total of 100 hours that we can spend on electronics available in terms of man hours available. We have 100 man hours available for assembly and 65 hours available for finishing. Each week we have that. So how many of each model should we be able to produce each week if all of the available time is used? So what they've done is and this is kind of a real life math solves the problems of businesses scenario where we're calculating our production rate. So we have 3 equations. If you read them horizontally, you get that a 2x plus a y plus a 3z equals 100. And you get a 2x plus a 3y equals a 2z. Oh, no, I'm sorry, plus a 2z. And that equals 100. And we have a 1x plus a 1y plus a 2z, and that equals 65. Okay, let's just step into this, and we'll call this E1, E2, and E3. We're going to pair up E1 and E2 and try to figure out how to cancel it. We can cancel it by, let's multiply E2 by a -1. So we get a 2x plus a y plus a 3z equals 100. And we get a -2x minus a 3y plus a 2z, and that equals, oh, I'm not changing my signs, negative, negative, and this should be a negative 2z. Negative 1 times times 100 is a negative 100. Okay, so when we pair up E1 and E2, the x's cancel, and we get a negative 2y plus z equals 0, and that is our E4. Okay, now let's come back and let's pair up E1 with E3. And we get a 2x plus a y plus a 3z equals 100. We'll take E3, we'll multiply it by a negative 2. We'll make x our variable that cancels. Negative 2x. Negative 2 times y is a negative 2y. Negative 2 times a positive 2 is a negative 4z. Negative 2 times 65 will be a negative 130. My x's cancel. I get a negative y, a negative z, and that equals a negative 30. That is my E5. All right, we're going to put those two together and cancel. I'm going to get a negative 2y plus a, oops, that is a z. Let me make it without the bend. A z equals 0. I'm going to cancel my, my z's are going to cancel. There's my E4 and E5. The z's already cancel. A negative 3y equals a negative 30. Y equals 10. All right, y is 10. I'm going to sub y into one of these E4 or E5 equations and solve for the z. Let's do it in the bottom one. Negative y minus z equals negative 30. The value of y is 10. Minus z equals negative 30. So a negative 10 minus z, negative 30, negative z. Going to add 10 to both sides is a negative 20. Z equals a positive 20. Okay, now what do? We have a y and a z. We go back into our E1. We have a 2x plus a y, which is 10, plus a 3z, which z is 20, equals 100. 2x plus 10 plus 60 is a 70, is 100. Subtract 70 from both sides, and 2x equals 30, x equals 15. All right. We would then take these these values for x, y, and z, sub them into each equation to make sure that we have found a solution that works for each. These answers do check out. Our final answer is that they want to know, let me read the question again, how many of each model should be produced each week if all of the available hours are spent? So we would be making 15 Model X TVs. We would be making 10 Model Y TVs, and we would be making 20 Model Z TVs. And that is your answer. So in this section, 4.3, you're going to be doing word problems with linear equations. When you start off, label your variables. Set up your equations. If you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations. You're free to do your equations as 1 variable equations or 2 based on what's easier for you to set up. Okay. wish you the very best.